Welcome back to Namaste Node.js Season 2 and we are building DevTinder. In this episode, we are going to talk about authentication and we are going to see that how you can safely store your password into the database, and we are going to make our application very safe and very secure for all the users who use it. Okay, so without wasting any time, let us just get started and dive deep into the code very soon. Okay, so let's just start. Now, the first thing that we will do is that we will store our passwords, right? We store our passwords in plain text over here, right? We can read it, alia@123. But our passwords should not be stored in plain text into our database. There are a lot of security issues if you store passwords like this, because these passwords are readable. I can read it. So the password should be stored in a hash format. Password should be stored in an encrypted format. And nobody should be able to see the password in the database. Okay, so suppose if the sign up API, when the user is registering onto our platform, when they are calling this sign up API, and if they are giving the password as elon@123, the password stored in the database should not be elon@123. It should be a hash of the password or an encrypted password that should be stored into the database. We will shortly see that how we can implement this, how we can keep our password safe into the database. But before that, let me just go back to our application and let us check our sign up API, right? In this sign up API, there are a lot of issues. We will improve our sign up API. Basically, this sign up API is for registering a new user. Suppose a new user is coming onto our website. So this is the entry point of any user onto our application. And if you will see, this sign up API is not very secure, right? The first mistake over here is, remember in the last episode, I told you one important major thing, right? The important major thing was never trust request.body. Never ever trust the request.body. Because see, this request.body over here is the data which is coming from the API. And an attacker can send any malicious data into this API and that will be stored in the database. In the previous episode, I spent a lot of time to tell you that how to enter schema validations, how to add checks on the API level, right? There are so many checks we need to keep our data safe into the database, right? Similarly, this is the entry point of the application and our sign up API should be very, 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 very safe. So never trust the request body. Let me tell you how the flow should be, right? Even before we create a new instance of the user model, first of all, the first thing, as soon as somebody hit the sign up API, is the first thing that should happen is validation of data, right? First thing should be validating the data. If the data is not correct, throw an error, send us an error response, and don't let user register onto your platform. The first thing should be validation of the data. Once your data is validated and you have seen that, okay, first name is there, last name is there, email ID is there, password is there, everything is correct, then you should encrypt your password, encrypt not my password, encrypt the password, right? And then store this into the database. That's how you should do it, right? First validate, then encrypt the password, then store the user into the database, right? This is the flow should be. Now let us just write some code to validate, right? Then encrypt the password, and then we will save the user. Okay, let us just do that. So there are different type of validation you can write, right? And you can also validate the data right at over here, right? Over here I can write the code for validation. But let me tell you a standard good practice, a industry practice for doing this, right? So sometimes we create some helper functions, right? Sometimes we create some utility or helper functions where we will validate our data. Okay, so let us create one function for you, because see, I want to give you the knowledge so that you can write a good scalable code, right? So validation, you need to keep the logic of API over here, right? you don't need to do everything over here in the signing API itself. You should create helper functions for doing all these activities. Okay. So what we will do, we will create a helper function. How do you create a helper function? Let us create a new file for it, right? Or maybe let us create a new folder. Okay. In the src, let me create a new folder and let me call it as utils. Either you can call it as utils, utility functions, or you can call it as helpers, right? I can also call this as helpers, but let me call this as utils because I don't know, I like that nomenclature. But you can, I have seen in the projects, some people write helpers, some people like utils, whatsoever, right? Whatever name you wish to give, please give it. And then let me create a validation.js. Okay, so I am creating a new file. Now in this file, I will do all kind of validations on my data. What is a good practice? To create a validator function. Okay, so I will create a function to validate this sign up data. Okay, so let me name this as validate sign up data. Validate sign up data. Okay, so I will just validate this data and I will over here take my request. So over here I will send this request, right? I will send this request and this request will come over here. Now I want to validate the request body from here, right? How do you validate the data? So first of all, let me take out all the fields, right? What are required? Take out all the fields from the request.body. Okay, from the request.body, my API is expecting the user to pass in first name, last name, email ID, and password. Okay, these are the things: first name, last name, email ID, password. First name, last name, email ID, and password. Okay, these are the things I will extract from my request body. Okay, I am just doing a JavaScript object extraction from here, right? I am destructuring this object. Now what I will do is, one by one, I will validate everything. First of all, I will check if my first name, last name is correct. Then I will check email ID. Then I will check password. Okay, so let us write if condition. If my first name exists, right? Suppose if the first name is not present, right? Or maybe I can check if the first name dot length, right? Remember, if the length is greater than 4. Okay, so first of all, let me check if the first name at least exists, right? If my first name exists, okay, if my first name is not present or my last name is not present, right? Suppose if you are not sending both of them, then I will throw the error, right? Let me just throw an error, throw new error, and I will say first, maybe name is not valid. Okay, let us just call this as name is not valid. Okay, or please enter the name, whatever you want to write. You can write your own, your own error message. Then I can do else if. Now I will check if the length of first name, right? If my first name dot length, right? My length should be, remember in the, I have also kept these check at the database level. Remember, if you go to the user model on the first name, I have checked the minimum length and maximum length, right? You can either keep it like this. You can either, if you want to check the length over here, that the length should be greater than 4, or maybe suppose if the length is less than 4 and the first name dot length is less than 4, or either the length is less than 4 or it is greater than 50. So what I will do, I will throw an error, right? I will throw an error. So you can keep these checks over here, or you can even rely on the checks which are there on schema level, right? But I am saying that you can keep these type of checks and return the appropriate error message, right? You can say that, okay, first name, first name should be 4 to 50 characters, right? So you can, similarly, you can add these validations, and you can add these validations for last name also. Now I am not writing all the logic. You can write all your logic, right? Make your API as secure as possible, right? And even if you don't write this, we will get the error from the model level, right? Over here I can get the error. If you are not writing this validation over here, I can get the error from here also. Okay, so you can even skip this validation if you want to, right? You can just skip this validation. Okay, so if you want, you can skip this validation. So if you will skip this validation, my over here the validation will work. Okay, cool. So now what I will do is I will now check my email ID. How do you check your email ID? Remember I told you there was a library validator, right? Remember I had a npm validator library. This, let us use the same, right? We already have that installed in our project. So let us use the validator, validator, validator is equals to require and then validator. Okay, so I have my validator library over here. Now I will check if my validator dot is email, sorry, my bad, validator dot is email, right? There is a function is email and it takes the email ID and it checks whether this email ID is a correct email or not, right? Whether, so basically see, it will check the validations like if there is an @ present or not, if there is a dot present or not, right? So all these validations, this validator function will take care of. If the validator dot is email ID is not true, right? If it is not a valid ID, right? Don't forget to put this not sign, right? Then I will throw a new error, email is not valid. Cool. Then I will do is password. So is password is the wrong function, right? This autocomplete is, don't trust the autocomplete, right? There is no function like is password. The function is strong password, okay? If this is a strong password, only when. Otherwise, I will throw an error and I will say that the password is not strong, right? Or I can say, please enter a strong password, right? Please enter a strong password, right? You can customize your error messages. I'm just writing some dummy error messages over here, right? So now what I am doing is I am explicitly validating each and everything. Whenever a new user is coming in, I will check if the first name exists, last name exists. I will then check if my validator dot is email is correct, right? Email ID is an email ID and the password is strong. Only then I will move ahead, right? So this is my validation function. You can create a validation function for yourself and can test all these data. Okay. And now I will just export this module.exports and now I will export this validate sign up data. Right? I have exported this validation. Now I will go to my app.js and now I will import it, right? How do you import it? I will just extract that out from require and then I will pass in /utils, right? Utils/validation. Got it? My validation.js. Now I will extract my validate sign up data from there and now I will validate the data. How do you validate the data? You will validate sign up data and you will pass in request over here, right? Whatever the request is coming, I will validate it over here. So instead of writing all that logic, where is my validation? All that logic over here, I have extracted that logic to a new file. This is a good way of writing code. Now my code is clean, isn't it? My code is clean. Right? And everything that you do, right? You are doing all these validations. So do it inside a try catch block. Why? Because see, suppose if any of the validation is failing, right? Suppose if any of the validations fail inside this function, suppose if any of these validations fail and I'm throwing a new error, whenever you will throw this new error, if you are doing it inside a try catch, your catch will catch it and that error will be sent back to the API, right? So this error will be sent back. Let me just write it properly. You can write it like this, ERROR and error and then colon, right? Error colon and then there is a error message in front of it, right? So you can just write it like this. Cool. So if anything fails over here, it will be catched from this catch block. Okay. So write it inside a try catch block. This is a good thing. Now, are my validations correct or not? Let us just test this first of all, right? Let us just test it. So suppose if somebody is trying to send an empty first name, okay? Let us just try to see if I'm trying to send an empty first name. So let me send it. It says name is not valid. See this, right? It says name is not valid. It was caught in our validation. Name is not valid, right? Suppose if the name is correct, but the email ID is not correct. Maybe let's say I wrote elon@gmail.com, right? This is not a correct email ID. Hope it will not work. Send it. Yes, see this. Email ID is not valid, right? So there should be an @ over here. Suppose if I'm not writing a strong password, I'm just saying 123. Okay. I'm just saying 123. This is not a strong password. It says, please enter a strong password. So I am just trying to make our API very safe and I'm just sanitizing and validating my data before doing anything. Okay. So this is how you do it. Now, once I have validated the data, and if I will enter a strong password also, now if I will send, so my user is added successfully into the database. If I'll refresh it, see, the user is added successfully. Now I will change this password to an encrypted hash password. Okay, I will change this password to an encrypted hash password. We have done this validation. Now I will encrypt the password, then I will save it. Okay, now I will encrypt the password, then I will save it. How do you encrypt the password, right? For that, I will use an NPM package. That NPM package is known as bcrypt, right? This is a very famous NPM package. If you'll go, you will see that there are 1.4 million downloads. 1.4 million downloads, right? So it's a very famous package. So this package basically gives you functions to hash your password and then to also validate your password. Okay, so if you'll go read the documentation, there are different functions out there. So we will be using this technique to bcrypt.hash, right? So this function we will be using. Let me just read the documentation yourself, right? I am not going through the documentation, but read this documentation yourself. But for now, we will have to install this bcrypt, right? So let me just close this function, right? I'm closing this server. npm install bcrypt, right? npm install bcrypt, right? As soon as I will install bcrypt, my bcrypt library has come to us, right? Now I can just write bcrypt functions, right? So now if I can just do like this, right? Bcrypt, right, is equals to require, not crypto, bcrypt, bcrypt. Okay, so now I have required my bcrypt. Now what I will do is I will do bcrypt.hash. So basically I will create a hash of this function, right? Hash of this function. And do you see that bcrypt.hash function basically, see, with promises, you can use bcrypt.hash with promises. Basically your bcrypt, when you do bcrypt.hash, it will return you a promise back. And how do you hash it? You will just enter the plain text password. Then you will have to enter the salt rounds, right? So let me just tell you the encryption method. First of all, let me just write the logic, then I will tell you, right? So first of all, I will basically try to create a password hash, right? I am creating a password hash, and this password hash will take my bcrypt.hash, and then over here I will pass in password, right? Where is my password? I will get my password. I will get the password from here. Password is equals to, I will get this password from my request.body. Okay, so this password comes from my request.body. Over here I will pass password, right? And the second argument will be how many number of rounds of salts. So see, basically if you read more about these hashing algorithms, you will see that, okay, there are, password, to hash a password, you need some encryption algorithm. When you do a bcrypt.hash, it creates a hash using a salt and a plain password, and then how many number of rounds that salt should be applied to create the password. The more the number of salt rounds, the tougher the password to decrypt. Okay, remember, the more encryption level will be, the more tough your password will be, more tough to break. Got it? But the good number or a basic number, decent number is 10, right? So basically it says salt round. So assume that, so let me tell you the process of encryption, right? Let me take 2 minutes to explain you that. When you encrypt a password, see, suppose your password is Akshay, right? Let me just explain you a little, because my teacher instinct isn't allowing me to go ahead without explaining you this, right? So suppose if your password is Akshay, now you want to encrypt this Akshay, right? Or suppose passwords are generally not Akshay, right? It will be something like this, Akshay@123. But still, this is a plain readable text. Now, what will you do is, you need a salt. You need a salt. Now, you have to do your own research because, see, it is a very big topic, encryption, right? And how do you hash, right? Calculate the hash of passwords. But what I need is, I need a salt. And this salt is a random string, right? It could be something like this, right? With special characters and whatnot, right? Something like this. Suppose this is the salt. Now you take this plain password and you take this salt and then you do a multiple rounds of encryption, salt rounds. And see, and in my function bcrypt.hash, right? In my function bcrypt.hash, there are two ways. You can either generate a salt also. There is a function bcrypt.generate a salt. It will generate a random salt for you, right? It can generate a random salt for you. Do you want to see this salt? Do you want to see this salt? Let me just show you the salt ones, right? Can I show you the salt? Okay, chuck it, right? You can just go and run this up code. You will see the salt. But salt is something like this, right? And random, kind of like a big string. Now you take this salt, you take your plain password and then do salt rounds on it, and the encryption level increases. So we are just entering 10 rounds, right? So it will keep our password very safe. It's a standard number. That 10 rounds is a good enough strong password. If you do 100 rounds over here to make your password very, very strong, so it will take a lot of time to generate your hash. Okay, it will take a lot of time. It will take a lot of time to compare also, right? Suppose if you want to validate your password, it will take a lot of time. If you do less number of rounds, that means your password is not that safe. Okay, so 10 is an optimum number. Keep it like this. It will generate a hash and it returns a promise. So write and await over here, and async is already there. So now this will create a password hash. And do you want to see a password hash? Let me just show it to you. Let me just show you password hash. Okay, so let me just show you password hash, and let us just hit the sign up API, and let me hit it with Elon1. Otherwise it will say the email ID is already registered. Hit it. Oh my god. Oh, server is not running. npm run dev. Hit enter. Now let me go back, send it up. See this, user added successfully, and this is your password hash. Do you see this? This is your password hash over here. So now if you will go to the database, if you refresh the page, the password over here, okay, the password is stored Elon123 because I am not storing the hash in the database, right? But this password hash was created. Now do you think this is your password? You entered Elon@123, but this is your password now. Do you see this encrypted string? So now this password is kind of like almost unbreakable. If somebody, suppose, see, I send this string to somebody, right? If I will send this string to somebody, still nobody will be able to figure out that this is Elon@123. This is what is the power of encryption. Once you encrypt it, you cannot decrypt it. Once you encrypt it, you cannot decrypt it. Okay, now you will ask, Akshay, then how will we validate? I will tell you how to validate, right? But think about it. Once you have encrypted the password, you cannot get the plain text back. Only the user who has entered, right? Suppose if the user is entering this password, only knows that what was it, right? If he has remembered. But this is a very tough encryption. It is very hard to decrypt this. Got it? So this is how you store your password. Now I want to store this password instead of these passwords, right? So let us just store this password. How do you store this password? I will have to, now when I create a new instance of user model, over here I should be passing this password hash instead of password, okay? First of all, this is a very bad way of creating an instance. You directly get the request.body and you passed everything inside this, right? So it's not a good way. A good way is to explicitly mention all the fields, right? So what all fields I want? First name, right? First name, last name, email ID, and password, right? And the password should be my password hash. Got it? Only these fields are allowed, right? Only these fields are allowed. Suppose if somebody else is sending something else, right? Suppose if somebody else started sending XYZ over here, right? Everything will be ignored because I am just concerned about 4 fields now. Suppose if you even send an XYZ from here, then what will happen? XYZ will be ignored, right? Nothing will be sent to the database, right? So what I will do, first name, last name, email ID and password, and the password is your password hash over here. Now where will this first name, last name, email ID come? I will extract it from here, first name, last name, and then email ID, and we need a password. Cool. So we have got this now. Now my API looks much better, right? So what I am doing is, as soon as the user is coming to sign up, I am first of all validating the request, right? Because never trust request.body or request. Whatever the request is coming, never trust the data inside it. Okay, so I'm validating the sign up data. Then I am just extracting these fields out. Then I am creating a password hash, and then I am storing this password hash. Now when you will save a new user, it will be encrypted password, right? There will be password encrypted, right? Suppose if I save elon2 at the rate gmail.com, right? If I send it, user added successfully, and if I go back, refresh my database, if you will see the new user, do you see? Now my data is perfectly good, right? Now my data has a hashed password over here. Nobody is able to see the password, whatever the user has entered. This is a good way of storing the passwords. Hope you would have understood this. Hope you would have liked this, right? This is the safe way of storing the data. And now let me, we have older users. I don't want all these users, right? Let me just delete the users with the plain password, right? Let us just remove it, right? And then we will move ahead in the code, delete it, or maybe let me just drop the collection itself, right? Let me drop the collection. You should not have a habit of dropping the collection. This is a very bad thing which I am doing. I am doing it and I am telling you this is a very bad thing. Never drop your collection. I am dropping the collection because I want to clear my database. If you really are sure that you want to clear the user table, user collection, then only drop it, right? Otherwise don't. Okay, so let me just register myself, akshay@gmail.com and akshay@123. If I send it, now you see my users, I will have a good object now. I will have a good document with the password encrypted. Now all the users who will come onto our platform will have their passwords encrypted. Amazing, right? So it was easy, isn't it? You just have to use this bcrypt library. Now, this was the first part of the video. In the next part, I will talk about how do you log in, right? Now, when I will log in, I will have to check for the password, right? So we will create a login API also. Right now, we have a sign up API, but there is no login API. So let us build that kind of authentication also. So suppose the user has signed up. Now we want to validate this password also. We will build it later on. But for now, this is the thing you have to do. First of all, let me give you the homework before we take a break, right? The first thing you will have to do, validate data in sign up API, right? And you have to create a helper function. Remember that, right? That is, you make a habit of creating helper function, utility functions, right? That will make your job very easy. Once you have validated the sign up data, then you will have to install bcrypt library, right? So that you don't forget the name of it. I am just writing it over here, bcrypt package, right? Install bcrypt package. Now you do have to do create a password hash using bcrypt.hash, right? bcrypt.hash, okay? And save the user with encrypted password. Got it? So this is what you have to do. This is your homework for now. Take a pause over here, do this homework, come back, and we will continue building our DevTinder. Welcome back, my dear friends. Now hope you have created the hash of your password and you have started storing hash in your database. So this makes your password very, very safe for all the users who sign up into your application. Okay, so our sign up API is safe and secure now. Let us now create our login API, right? Let us create login API. First of all, let me close all these APIs, right? Now let us create a login API. How do you create a login API? You will have to again write app.post. It will be a post API, and then the path should be login, and then I will write the handler for it. Let's create this as an async handler with a request, comma response, right? And over here, empty, right? Everything is empty. Let us just write our try catch block. Let me copy the catch block because it remains the same for my application. But you can, have different type of catch blocks also, like the user error can be different, right? So cool. So now we have this try catch block over here. Cool. So now what we will do is inside our try catch block, let us write for user login, right? Suppose this is the login API. This login API will take what? Your email ID and password, and it will validate if this email ID and password is correct or not. Okay. First of all, it will validate if your email ID and password is correct or not. The first thing that I will do is I will extract the email ID and password from this request. Right. Let me just create this from this request.body. I will take out my email ID and password. Now I can keep a check also, right? I can just validate if my email ID is correct, right? So let me first of all check if the email ID that user has entered is correct or not, right? Let us just sanitize the data. I am not sanitizing password because there is no password sanitization like that, right? You can just have any password. You can just send anything over here. It will not matter much. But let us just see if our email ID is correct. If the validator.email ID, you can just check it, right? Or maybe I'm just giving you as a homework, just write a check for email ID validation. Now let's come on to the main logic. Suppose if your email ID and password you have got. Now we need to check whether the email ID and password is correct or not. How do you check it? First of all, what I will do is, how do you check it? So let me just go back to your bcrypt library and show you that there is a function to check which is known as bcrypt.compare. Now this bcrypt.compare, and let me tell you how to use this function. Okay, so is password valid, right? Let me write it down. Is password valid, right? Because this returns you a boolean, right? This returns you a boolean. So is password valid? It will be true or false if my bcrypt.compare, if you will compare, suppose the password which I wrote was elon@123, right? And over here I will pass in my password hash that I have stored in the DB. Where is it? In my logs it will be there, right? Where is it inside my log? Yes, this is the password. So basically this, right? This is the password log, right? So basically this API works like this. If you do a bcrypt.compare, pass in this, right? Pass over here, and then you will pass the encrypted password, right? So this is what the documentation says, my plain text password plus the hash. You pass the plain text password and you pass the hash. So what will happen is it will return you the true or false. Got it? So this is how this API will work, and it is again a promise, so I'm writing it like this. But first of all, I will have to basically find my password, right? So this password which is coming from the request, right? See, suppose if I am creating a login API, let me create a login API here and let me show you. Let us duplicate this. Let me just duplicate this over here, and then you will be better able to understand what I am trying to say. Okay. So this is the login API, right? Here is my login API. Now if I go back to body, over here I will just get my email ID and password. Okay. This is my email ID and password. So this password that you are sending from here will come from my request.body, and this will be the password, right? This is the password. So this is the plain password which I have to pass in over here, right? This is the plain password. Now over here, I need to check the password hash which I have stored in the DB, right? Over here, this is the password hash which is stored in the DB. So first of all, what I will do is, before passing over here, I will check whether the email ID, see, suppose if somebody is trying to log in with random email ID, this email ID is not there in my database. So first of all, I will check whether this user is present in my database or not. If the database mein user is present, then I will check whether the password is correct or not. Okay. So what I will do is, first of all, I will check if the person who is trying to enter or trying to log in, is the email ID even valid, right? So how would you check that? For that, I will try to find a user. We have a user model, right? I will do await user.find one, right? I can do find one, or you can do whatever, right? Sorry. You can do find by, find one, right? You can do find one, right? Or you can just do find also. One and the same thing. Find one will return you just one entry. Because our email IDs are unique, so if there will only be one object, right, which will come, right, if in case. So now I will find one email ID. Suppose if the email ID is valid, then from the database I will get the user object, right? If my email ID is not valid, what will happen? My user will be undefined, or my user will be null, because there will not be any user, right? So I will check. If my user is not present, then I will basically log, or basically send the response, or let me just throw the new error and let me say email ID is not present in DB. Okay. So email ID is not present in DB. This is the error that I have thrown. Now I will check once. Suppose if my user is present, suppose if I got the user back, and if the user is back, now I will compare the password which we have got from the request to the password that is stored in my DB, where user.password. Okay. So now I will check if my password is valid or not. And if my password is valid, what will I do? If my password is valid, is password valid, right? Then what I will do? I will just send the response back. I will just send, right, user login successful, right? Login successful. Got it? So if my password is valid, then I will say login successful. If my password is not valid, else, right? If my password is not valid, then I will send or maybe let me just throw new error, and I would say password is not correct. Got it? So shall we test our logic? Do you see this? Let me just recap the code once again, and then I will test the logic. So see, whenever, you don't have to remember any code. You don't have to copy me. Just use your brains, right? What will I do? Suppose if I have to check the login, right? See, a lot of students I have seen, they try to memorize whatever I am coding. See, I don't memorize. Why? Because I am writing certainly, right, the logic which is coming to my head. What is coming to my head? Suppose if I am hitting, like the user will hit the login API with an email ID and a password. First of all, I will check whether this email ID is even there in my database or not, right? If the email ID is not present, then say that, okay, email ID is not valid. User does not exist, kind of like thing, right? But now, suppose if the email ID was present, suppose if the email ID was akshay@gmail.com, because this user exists in our database. Now I will check whether the password is elon@akshay123 or not, right? So for that, we will do this. If the password is valid, say login successful. If the password is not valid, say password is not correct. Okay. So let us test this up. Now, if I send this, it will say password is not correct. Password ID is not correct. Okay, sorry, password ID, it should be password not correct. Okay, password not correct. Suppose if I entered random email ID, it should fail. It should say email ID is not present in DB. Got it? Now, suppose if I enter the right password and right email ID. The password was akshay@123. If I hit login, it says login successful. Do you see this? We have built a small authentication system, right? We have built a small authentication system, isn't it? Right? This is how beautiful it is, and you can write your code easily. It is not very complex. A lot of people and a lot of students say, Akshay, I don't know how, I don't understand what is authentication logic, this, that. No, nothing. First thing, what we have done, right? It was very easy, right? In this whole episode, I just did password hash and stored the password. And now I am just validating whether the password which was there in the database is the correct password which the user is entering or not. Okay, that's all I am doing, right? We will come on to the advanced level of authentication also, where we will use JWT token and all that other stuff. But don't worry, we will do that very soon, right? But now, this is what it is. Login successful, password is not correct. Now, let me tell you one important thing. Never ever disclose important information. Suppose, see, I am disclosing a lot of extra information. Suppose if my email ID is not present, so the email ID is not present in DB. I should never tell the user whether this email ID is present in my DB or not. This is known as information leaking. Why should somebody, suppose I am an attacker, I am just trying random email IDs. I am just trying random email IDs on your database. And your database is telling me which email ID is present in your database and which email ID is not present in your database. That is not a correct thing, right? So always never explicitly write these error messages, right? Always say that, okay, if the email ID is not valid, say invalid credentials, right? Invalid credentials. You are not saying whether the password was invalid or whether the email ID was invalid. You don't have to expose your database, right? This is kind of like a extra information which we are saying email ID is not present in DB. A good way, just say invalid credentials. If the email ID is not present, invalid credentials. If the password is not present, same thing. If the password is not correct, same thing, invalid credentials. So the attacker should not know whether your email ID was wrong or the password was wrong. Okay, so for everything, suppose if I have invalid credentials, if my email ID is not correct, suppose my email ID is correct and the password is not correct, right? Then it should say me invalid credentials. And if both of them are present, then only it should give me login successful. Now for people who don't know, who did not understand that why I am keeping this error messages same for both, try to research, try to find out that you should never be saying that, okay, your email ID is not present in database. This is like exposing extra information. You don't have to. Why should anybody get to know whether the Akshay Mar7 or Akshay s2e9 is registered onto the platform or not? Nobody should know that, right? If Akshay s2e9 and password are valid together, that can only happen when Akshay is entering it. Then only you should get to know anything, right? That login is successful. Otherwise, don't give extra information, okay? Just say invalid credential and throw the new error. Cool. So this is how you validate the password. Now that we have created this login API, it is very, very secure and safe up to a level. We have stored the password in a hashed format. We have checked that how can we validate these passwords, right? We have done a lot of amazing things. In this episode, we have built a small level of authentication. Now, let us make our app much more secure. In the next episode, we are going to talk about a little bit more of an advanced authentication technique, which is known as JWT token, right? We will be sending a token, we will be creating a token, and we will be putting that token into the cookie and sending it back to the user. Now the user has the cookies. And now the user, whenever a request will be made to the server, the cookie will be sent and we will validate that the user is authenticated or not, right? It will be a very amazing session, the next session. So hope you are excited for that. So do this homework, right? Whatever I am giving, right? Do this homework. This is the homework for this episode, and then come back and watch the next episode where I will show you the advanced level of authentication. Okay. So let me just give you the homework before I go. The first homework is create login API. Create login API and write the logic by your own. You should be able to write the logic by your own, right? Validate the data and then compare passwords and throw errors if email or password is invalid. Right? So whatever I did in this episode, you have to do it in your system, in your application. Okay. So created login API. Let me just store this also, right? Let me just commit it. Cool. So now I have added this onto our GitHub repository. Okay. So now this was it in this episode. Hope you are enjoying these episodes. Hope you are liking it. We are going on to some advanced topics now. We are going to cover the password authentication. Now we are going to see the token based authentication in the next episode. And we will do and build a lot more things inside DevTinder. Hope you are excited, right? So please, watching just the videos will not help you. Please code it. Push your code onto GitHub, maintain your GitHub repository, maintain notes, whether in your GitHub repository on any digital notes, or if you are writing handwritten notes, make your own notes, right? But making notes is very important. Coding along with me is very important. That is when you will learn. And if you are liking everything, if you are liking Node.js, then please share a word about us on social media. Give us a shout out, give me a shout out. It will mean a lot to me, right? Thank you so much for everybody who is giving me a shout out on LinkedIn, right? There are so many people who keep writing a lot of good stuff about Node.js. If you are really liking it, just appreciate us on social media. That would help us a lot, right? And I feel very happy. Do tag me when you do that, right? It means a lot to me. That's all in this video. See you in the next video with a lot more advanced concepts. And thank you so much. And for then, bye-bye.